Hello, ladies and gentlemen. Welcome. If you're fresh from coming off from the unequivalent fractions, today we're going to be talking about, equivalent fractions. Today we're going to be talking about how to solve inequivalent fractions. That means fractions that have different denominators. And you'll see that half of it is the same as yesterday, but the other half is getting us to making it equivalent. So what do I mean by that? The way we solve inequivalent fractions is by making them equivalent and then solving them like normal. So how do we make inequivalent fractions equivalent? How do we change their denominators to be the same? Well, it's actually pretty easy. And let me show you how. Here's a trick to do it. So I've got this question here, 1/2 plus 1/6. Normally, I couldn't add it. Like right now, I can't add the numerators because their denominators are different. I've got a 2 and a 6. So I need to make them the same. The way we do that is quite simple. We just multiply each fraction by its opposite denominator, or multiply the tops and bottoms of each fraction by its opposite denominator. Let me show you what that looks like. So I'm going to rewrite them, and I'm going to use different colors to try and make it as clear as possible. So I've got 1/2 plus 1, and I'm going to make this purple to make this, again, as clear as possible, 6. And so what I'm going to do, in order to make their bottoms equivalent, I'm going to multiply the tops and bottoms by the opposite fraction. So this 1/2, I'm going to multiply the tops and bottoms by the 6. 6 times 1, 6 times 2. This 1/6, I'm going to multiply the tops and bottoms by the 2. So 1 times 2 and 6 times 2. And I'm going to rewrite them now and see what my new equation is. Well, 6 times 1 is 6. And 6 times 2 is 12. So I get 6/12 plus 1 times 2 is 6. And 6 times 2 is 12. Oh, sorry, no. 1 times 2 is not 6. 1 times 2 is 2. Silly Mr. Grapp. And 6 times 2 is 12. So I got 6/12 plus 2/12. Oh, well, now look. They are the same denominator. They are equivalent. Now that they're equivalent, I'm just going to add and subtract them like I did before, like we did in our last lesson. Let's add the tops together. 6 plus 2 equals 8. So my answer is equal to 8/12. And then I just need to ask myself, do 8 and 12, do they share any common factors? Well, I hope you're hearing Mr. Grapp say it enough by now. Look at them. They're both even. Yes, of course they do. If they were odd, it's possible. But because they're even, they absolutely share something in common. They at least share a 2. But as you'll see, they do share a bigger common factor than that. So now that it's necessary, I'm going to put it in simplest form. How do I do that? Well, I'm going to take the 2, the denominator, and the numerator, and I'm going to try and find a common factor between the two of them. 8. How can I get to 8? Well, I get to 8 by using 1 times 8, right? 1 times 8, 2 times 4, and that's it. That's actually it. How many ways can I get to 12? And again, I'm really only curious about the ways that are using these factors. Well, I can get there using 1 times 12. I can get there using 2 times 6. I can get there using 4 times 3. And I think that's actually, coincidentally, all the different ways I can get to 12 as well. Let's see. Do we have anything in common? Well, we've got the 1s in common. We've got 2s in common. But I see, of course we got 2s in common. They're both even, right? But I also see I've got a bigger common factor, and it's these 4s. So now I'm going to go back and divide the top and bottom by that 4. By the top and bottoms by that 4 to get our final answer, which is 8 divided by 4, which is 2, and 12 divided by 4, which is 3. And there you have it, 2/3. That's our answer. I'll box it and call it a day. Oh, okay, Mr. Grapp. So you're saying this really isn't too different from solving inequivalent fractions. The only difference is we simply need to make them equivalent, and then we can solve it like we're used to. Absolutely. Let's see if you've got that down by looking at example 1. 3 plus 5 plus 1/3. Well, once again, these aren't equivalent, so I need to make them equivalent, right? So let's do that. Again, I'll be very careful and use different colors so that you can see it brightly. 3 and 1. 3/5 plus 1/3. To make them equivalent, we're going to multiply the tops and bottoms by the opposite denominator. So I'll multiply this first one, top and bottom, by 3. And I'll multiply the top and bottom of this second one by 5. And if you're wondering where I'm getting these numbers, just look at the denominators. This 5 is multiplying the top and bottom of the other one. This 3 is multiplying the top and bottom of that other one. Kind of makes a triangle if you look at it like that. There we go. I'm going to erase those white dots just to keep things clear. Awesome. What do I get? Well, I got 3 times 3, which is 9. And we'll make this pink. 9 all over 3 times 5, which is 15. Plus 1 times 5, which is 5. All over 3 times 5, which is 15. Again, that's exactly what we expect to see. And look at that. Common denominators. Now I just need to add and subtract them. 9 plus 5 equals 14. And that's my answer. Equals 14 all over 15. I'm going to ask myself, before I put a fork in it, I'm going to ask myself, can I simplify this any further, or do they have any common factors? And the answer is no. 15 is a prime number. Oh, no, it's not. It's not prime. What am I saying? But they don't share any common factors. 2, 7, 1, 14, 1, 3, 5, 15. No common factors. So it's in its simplest form, and there it is. That's why this step has a question mark, because you won't always be able to simplify. Sometimes you will, but not always. All right. Hopefully you got that answer. Let's move on to the next one and test. Pause it. I encourage you to pause it and try to do it on your own. 3/7 minus 1/8. Not the same denominator, so I'm going to make them the same. We'll start by going 3 over 7 on one side, 1 over 8 on the other. 3 over 7, 1 over 8. I'll multiply each top and bottom by its opposite denominator. So 8 times 3, 7 times 8. 1 times 7, 8 times 7. We're subtracting here, so I'll rewrite that there. Awesome. 8 times 3, that is 24. Over 8 times 7, which is 56. Minus 1 times 7, which is just 7. 8 times 7, again, 56. Now I just add and subtract the tops. Add or subtract the tops, I should say. 24 minus 7 is equal to 17, right? Yeah, 17, I believe. There it is. 17. All right. There's my answer. 17 over 56 is the answer. Now, again, I have to ask myself, do they have any common factors? And in this case, I can say no. The 17 is a prime number. It's 1 times 17. So I can't get to 56 using 17. Therefore, this is it. My answer is 17 over 56. I'm going to make that 5 a little clearer. 17 over 56. There you go. Okay, sweet. Let's just do one more now. Let's just do one more. 2/5 plus 3/10. Okay, again, multiply the tops and bottoms. So 2, 3, 5, 10. That should be purple. 10. All right, I'm going to multiply the tops of this one by 10. Bottom of this one by 10. Awesome. I'm going to multiply the tops and bottoms by 5 on the other one. Times 5 times 5. Equals what? Well, let's see. 2 times 10 is 20. So it's 20 over 50. Plus 3 times 5 is 15 over 50. There we go. Now I just add or subtract. Since I'm adding, I'll add them. 15 plus 20 equals 35. So my answer is, once again, just right there, 35 over 50. But I have to ask myself, is this in simplest form? Do they have a common factor? And here's another pro tip. If they end in a 5 or a 0, if both terms end in a 5 or a 0, it's divisible by 5. I noticed that both of these end in a 5 or a 0, so it's divisible by 5. So I know at the very least, it's not in simplest form, but we'll see if they have anything bigger than a 5 as a common factor. So we'll start with 35. How many ways can I get to 35? Well, I've got 1 times 35 and 5 times 7. That's another way to do it. I believe that's it. All right. And let's see, are there any ways to get to 50? Oh, there's a couple ways to get to 50, but again, I'm only really concerned about the ones that match up with my top factors. Can I get there using 1? Sure, 1 times 50. Can I get there using 35? No. Can I get there using 5? Yeah, 5 times 10. Can I get there using 7? No. Can I get there any other way? Maybe. Yeah, actually, I can get there using 25, but I'm not worried about it because it doesn't match any of my factors above here. I notice that the largest factor they have in common is the 5. So I'll divide both terms by 5. And I'll get my final answer. 35 divided by 5 is 7. 50 divided by 5 is 10. I'll ask myself again just to be safe. Do they have any common factors? Unfortunately, nope. 7 is prime and you can't get 10 using 7. So that's my answer. And there you have it, ladies and gentlemen. Solving equivalent or inequivalent fractions. That easy. All there is to it is, again, making it equivalent by multiplying the tops and bottoms by the opposite denominator, adding and subtracting the numerator now, and then simplifying if necessary. Sometimes it won't be, but sometimes it will be. So just always ask yourself, do they have anything in common? Do they have any factors in common? There you go, ladies and gentlemen. That will do it for this lesson. Join me in the next one when we learn about multiplying and dividing.